All right. Next up is day 5. That wasn't too bad. Okay. Day 5. How about a nice game of chess? You're faced with a security door designed by Easter Bunny engineers that seem to have acquired most of the security knowledge by watching hacking movies. What does that go to? Hackers, the film. The 8-character password for the door is generated 1 character at a time by finding the MD5 hash of some door ID. Oh, we got to use MD5 again. Okay. An increasing integer index starting with 0. So we can actually look for that. We had it here on 2015, day 4. Let's take a look at that real quick, just to remind ourselves how this works. So digest is MD5 compute. We have a prefix followed by a number. So this is the same kind of code where we put a prefix followed by a number. We look for the first 5 zeros. Yeah. Okay, yeah, and we do that here too. We do look for the first 5 zeros. If it does, the 6th character in the hash is the next character of the password. For example, if the door ID is ABC, first index which produces a hash starts at the 5 zeros is this number, which we can find by hashing that together. The 6th character of the hash, and thus the first character of the password, is 1. Okay, I think I understand what we're doing. So this should be fairly straightforward. And then let's see if this reformats it. It does. Grab this guy. This is the puzzle input, so we don't have an input file. That's fine. Git. Oh, no, nvim this. There we go. 2016. I'll get it right this time. And then 05. And then get rid of this. And then we should be good. We should say unsolved if we hit run. There we go. Okay. So we can just do this as a test and see. There's no parsing to do, but we can say let prefix equal ABC. And then for I in 0 dot dot, we want to say, what was it? Let digest equals MD5. Oh, we have to use MD5, right? Oh, we don't. We could just say MD5 : compute and then format it and then get the digest that way. Okay. And there I was doing an infinite loop. Here I'm going to try this. Format bang. Prefix followed by I. And then we're going to check digest of 0 and digest of 1. If digest of 0 is 0 and digest of 1 is 0. And we have to check the 5th nipple. Digest of 2 and FO is 0. Then we're going to println let's say digest of 2 and OXF. I guess that works, right? It's just a character, right? Oh, we have to convert it A, B, C, D, E, F. That's fine. Let's see what this does. At least we can see if it's working. Oh, and I don't have it stopping. That's a problem. I need to stop after we find the full password. 8-character password. So we have to count how many passwords. Let mud count equals 0. Count plus equals 1. If count is greater than 8, break. Like that. Okay. And I remember it's slow, so let's try cargo run release. 1815, so that's F. 18F47A30. 18F47A30. Okay. We just need to print it out correctly. But we can just use a different prefix, our prefix here. Actually, this is straightforward, right? We can just say let IDX equal to digest 2 F, and we'll just make it as usize. And we can just make the let result is equal to string. Yep, we'll do that, we'll do this, and then we'll just say if IDX is less than 10, then result.push b of 0 plus IDX as char, right? And then else result.push, and we want to do, I wonder if he cares about upper versus lowercase. It's a password. Password's supposed to be case sensitive, right? So maybe we care about it being lowercase like that, and then we do that, and then here we just say results. And let's see if we get the right answer here. It should be 18F47A30. Oops. Expected U8 found usize. Oh, okay. We can do U8. It's annoying that the quick fix is not working, but that would require a rebuild. 18P. Why does that say P? Why does it say P? Oh, because we have to subtract 10. Right, because we want, if IDX is 10, we want this to be A, so this has to, we have to subtract the 10 from that. All right, so that should be 18A47 something 0, A0, 18F47A30, right, okay, so now we just put our prefix in, and that should solve part 1. Not too bad. It's just really slow. 2.8 seconds in release mode, so it's probably like in the order of 30 seconds or so for non-release mode, for debug mode. All right, so this is what it came up with, 4543C154. Ooh, how about that? That's the right answer. I like it when it's the right answer. So there's no input file. 2016, day 5, part 1. Okay, so that's that. Let's see what part 2 has to offer. As the door slides open, you're presented with a second door that uses a slightly more inspired security mechanism. Unimpressed by the last version, in what movie is the password decrypted in order? The Easter Bunny engineers have worked out a better solution. Ooh, I don't want to watch a YouTube video right now, but that's linking to a YouTube video, which might be a Rickroll, so I'm not going to click it. Instead of simply filling in the password from left to right, the hash now also indicates the position within the password to fill. You still look for hashes that begin with 5 zeros. Okay, however, now the 6th character represents the position, and the 7th character is the character to put in that position. All right, so we're still finding the hashes that begin with 5 zeros, so we can do that one time and then use it for both parts. So it's time to refactor, right? NVim. And then what I can do is I can just save the first 8 hashes that match. Let's do the refactoring first. And what is digest? It's just a vector of something, or an array of something, a slice of something. It's a digest. Of course it's a digest. Which must implement deref if we can do the brackets on it. So let's just say we'll create an array of digests here. Digest, vec, digest. and I have to pull it in somehow. It's like MD5 digest. And then in parse, we're not really parsing, but we can do that. Pull this L out and put it in here. And instead of doing this, what we'll do is we'll store the digest. Self digest, push digest. Right, and then now we have to move all this down. Oh no, we're going to keep the counts. This stuff goes back down here. And that goes there, and we can get rid of all these guys. Yeah, and now here we just loop through the digest for D in self digest, and this becomes D, and then we need a closing brace. And let's see if we still get 4543 C154. Let's see if it even builds. I'm going to do a cargo clean so that I can get my quick fix list working, even though it's going to be slow the first time we build. Let's see if we get this thing working. Content modified. Oh, missing digest. Digest. Back new. All right. Now we have the quick fix list working. That's good. Okay, it built, or compiled. Let's see if it's still 4543 C154. It is. Okay, so we didn't break anything. So now part 2 should go very fast because we're just going to loop over the digest and take a look at. Okay, for example, if the door ID is ABC, the first interesting hash which produces this, so 5 goes in position 1. The previous method, 5017308, produced an interesting hash. However, it is ignored because it specifies an invalid position 8. Oh, so we have to go further. So we can't just use the first 8. I mean, we can use the first 8, but we have to keep going even more. Bummer. Yeah, Negforces says no duplicate indices. Okay, so what we can do is we can just save where we left off. We can make this, we can still do digest, but we'll put the count in here. Let's make it a usize. And we can say count 0. And now instead of the count, oh no, this is the index. All right, and then we can just say loop. Index. Oh, does it start at 0 or start at 1? It's starting with 0. Okay. So we don't want to increment index just yet. Self index, and then we can increment it self index plus equals 1. Okay, and then instead of this being in the parse function, what we can do is we can have it just say, oh, that would be neat, and make it an iterator. Just say, you know compute.next, and then just keep going for the next one until we have a value. Yeah, that would be a good thing. We have our combo. So here's how we did an iterator before. We just implemented iterator for a type. And we can't implement it for digest, but we can create our own struct type that does it. And basically what I want to be able to do here is in part 1 is just say next, right? For D in self next. And it just returns a digest, which is right now unknown. But we can say impl iterator for AOC 2016-05 right? That's all we need to do. Type item equals MD5 digest. AFN next, let self. Returning an option, self as iterator item. And now all we need to do is look for the next digest that contains, not this whole thing, but yeah, so we increment by 1, and if we start with 5 zeros, then we're going to return the digest, return some digest. And then we keep going. And that's all we need to do there. And then that gets rid of this, all of this stuff. Oh, we have to set it up with a prefix, right? We need to know what the prefix is. So we can just say self prefix, self index, and then prefix is a string. Where's my prefix? All the way at the bottom here. Okay. Comma. ToString. There. Parse then disappears again. We don't care about that. And then this needs to be what? Iter take 8? Does that work? And is that a digest? No, that doesn't work. Okay, so we can't do that. But we can do next. But I don't think you can say take 8 on next. I think you have to do it on the iterator. And then here let mut count equals 0. Oh no, we don't have to do that. We can just say if result.len equals 8, break. It's a little sloppy, but it does the trick. Oh, and we do need to save the entries that are found. So we have to say self digest push D. And now the question is, do we still come up with 4543 C154? No, we don't. We come up with the number 4. Why? Did this return none? No, this can't. This can never return none. It stopped after 1. Let's see if we can print. If we can debug out this guy. Bang. And see if we get 8 of those, and maybe I'm just messing something up somewhere. It printed the first one and then stopped. Huh. Are we getting a none? We shouldn't be. Right? Because we call next on this thing. Let's just try it here. Println debug out self next, and then we can just say 1 and 2. Yeah, there's 4 and there's 5. What's going on? It's like, the reason I'm confused is because this should keep going forever. But it shouldn't. Because result is clearly not 8. I'm baffled right now. Yeah, it's never getting there. It's just breaking. So this self next, for some reason, is not. This is digest, yeah. We can just say print called. At self index. Right? And then we should see those. So called it 0 for the first one, called it this one for the second one, called it this, and then it was never called again. Okay. While let sum d equals self next. Let's see if that works. Okay, that works. I guess you can't do it with a for loop. And we don't need this anymore. And then we'll see if this, if I fixed it back. What was it? 4543 C154. Yes, okay. So we're back to working condition. And now for this, we'll start by using the 8 we found here in the digest and then keep going. So for D in self digest. And then what we're going to do is we're going to use this. So 5 goes in position 1. So this is the index of the position it goes in, and that is the value that goes there. And only if there isn't something there already. So what we can do is just create let mut. And we can just create an array of 8 spaces. 3, 4, 5, 6, 7, 8. Yep. And then what we can do, oh, this goes outside the loop. And then what we can do is, oh, how do we know when we're done? I guess we can count every time we got a good one. Let mut count equals 0. And then once that's 8. So now we go through the digest. We look at position, 5, and then we grab that one. So let IDX is digest 2 and OXF. And this is going to be as u size because we're going to index into the array, and then let val is equal to d of 3 and OXF0 shifted down by 4. And we use this same logic here. So maybe we can create a 2char d val 2char of v, which is going to be a u8, and returns a char. And we just take this, instead of index, we'll just use v. And we just say a self-digest push. We want to say result.push this after we convert it to char. So val like that. So hopefully this still builds. This we can ignore for now. Oh, we just want to turn this. For self-digest iter. Okay, not worried about the warnings because that's all for part 2. Let's see if we get the same answer. Yep. Okay, so we haven't broken it yet. So now what we can do is if, and this is going to be as you wait. If if array of index is equal to space, then we're going to say array idx is equal to val to char val count plus equals 1. And we can't go beyond 8 at that point because there's only going to be 8 in there. So now we can say while count is less than 8. We're going to say let digest is equal to self next. And then we're going to use the same logic here. Copy, paste. And then the answer is going to be, how do we convert this to a string? Can we just do a collect? Let results colon string equals array.iter.collect. Let's see if that works. But it did panic. Index out of bounds. Lens is 8, but index is 12. Oh, right. Yeah, we have to ignore invalid indices. If idx is greater than 8, or greater than or equal to 8, continue. I think we have to do the same thing here, right? Let's try again. Decoder18, thank you for the follow. Welcome to the club. All right, that took a while. It took almost 6 seconds in addition to the 3.8 seconds it took for part 1, but let's see. Hey, look at that. That's the right answer. All right, that wasn't too bad. Meg Vorsa, thank you for the follow. Glad to see you're keeping an eye on the lab. All right, so I think we're good. Bacon, Clippy. Does Clippy have anything to say? No. I think we're, oops. I think we're ready to push. Git status, git add source, git commit -m 2016, day 5, part 2. Oh, it's rebuilding because I did a clean. That's right. Okay. Let's see. It's 8:30 my time. Should we try number 6?